Good morning. Dear principal, dear fellow professors and teachers, and dear students, this particular day, as it is shown here, reflects the way the science has to proceed, or in other words, how new phenomena in the world of things is taking place. Everything that you see in the universe or in the earth, on the earth, everything that you see is related to some kind of phenomenon influenced by various factors that have come all along from the birth of the universe. And of course, when I say universe, I mean it's a cluster of stars, planets that we have, and neutron stars, and even black holes. So keeping all these things at one point or the other, every phenomenon that has occurred right from the birth of universe, about 1375 crore years ago, it is giving a lot of impetus. Finally, the impetus has taken place in the form of human beings through one cellular molecule. So probably you are quite aware of it. So particular day we have chosen this Raman. In fact, Raman, I happened to listen to the lecture in 1970 when I was a junior research scholar at National Aeronautical Laboratory, Bengaluru. So that way I knew him, and of course in 1970 I attended his lecture. Of course, typical of his style, having a turban, and of course it gives a kind of impression what kind of person he is. That means he was. So he maintained that kind of stature right through. In spite of the fact that that time when he was young and carrying research, we were under the British rule. But still he maintained his own stature. So now coming back, so keeping all these things in mind, I framed my talk like this. Science unveils secrets of the nature and universe. So when I say this, I am quite aware that this talk attracts more questions than the answers available. Because when I say universe and nature, it comprises many things, not the things that we see with naked eye, but many things are happening at macro level and micro level and nano level and atomic level. So now, keeping this thing in mind, how do we relate the sequences of the events that have taken place to the material that we are familiar with now in the 21st century? How best we can utilize these materials and the various phenomena, physical laws that give rise to and bring a lot of benefits to the mankind. What I mean to say everything that is observable can be utilized because they are all evolved with the principles behind it. So science, science, science. So this is the way I have taken this title. So let us see how we are going to unveil, how we are going to uncover, how we are going to find out, how we are going to innovate. Various things. Of course, this lecture will not be complete. Only I have taken representative of the examples. Next. Yeah. To investigate anything that we would like to have, there are two things that are required. One is the microscope to see at the atomic level of the materials, and another one telescope to see far off planets, stars, and so on and so forth. The Milky Way. So this will give a lot of information to us. So that's how this slide brings you right from the far off places, planets, but also at the nano level that you see at the bottom, where we are with the atoms, right? And this is of course the universe. At 1375, 4 years ago, the universe took birth. So from that onwards, it expanded, still is expanding. So in this gamete events, so naturally, a lot of things are to be learned. Many things have to be observed. So everything that we observe could be utilized, could find applications. It's not that the scientists investigate and forget it. It may not be right now useful. Once investigation, finding, but at a later stage, it will be useful. Say when people talked about quantum mechanics in 1930s, people laughed, including Einstein, great Einstein. So he got spooky action at a distance. Of course, I'll come back to that. But this slide brings you right from the birth of the universe to the present day. Yeah, this is the periodic table that we are very, very familiar with. So unless there are materials, what can you do? So the basic thing is that one should have materials to work with. Whether you are pursuing computer science or mechanical engineering or electrical engineering or thermal engineering and whatnot, everything is related to the materials. So unless these materials possess certain properties, you cannot use them. Example, say for example, I am suffering from eyesight. So naturally I have to go for optics, glass optics. But I cannot use wood in place of glass. So glass should possess those optical properties, then only I can use for setting up eyesight. So everything has to be found out what it contains, what are the properties. So there are 6 properties. Of course, you can see the Mendeleev starting from his box investigation right to the last one elements in the periodic table that Yuri was in. It so happened both are from Russia. Right from Mendeleev to the last investigator was with 118 elements. Both belong to Russia. So it so happened that, of course, from this box, so naturally the questions will emerge. So the basic questions, see, my way of talking with you is to provoke everyone here. Not talking just like Ramayana or Mahabharata. But when I give a talk like this, I want to see that everyone is provocated. So that you come with a lot of questions. to hear? Last one is able to hear? So this periodic table, right now it is with 118 elements, but possibilities do exist to expand this. In fact, there was a theory. Even one can find 135, element 135. So where do they fit in? So one has to see the properties of that new element and place where in the right box with the known properties. But of course, out of 118 elements, still there are some elements whose properties are not known because they just live for nanoseconds. And they are made in accelerators, big accelerators with the powerful beams colliding many times and do study their properties, mechanical properties, because they would like to use for structural purposes. And so on and so forth, electrical engineers, they would like to know the electrical properties of materials. So naturally, that pushes us for further research in the area that you are going to do. So what kind of interest do you have? But otherwise, in the entire universe, or in the universe, or on the earth, we have plenty of scope, plenty of opportunities to study the materials from various angles. So this electron possesses four important properties: charge, positive or negative, next the spin, orbit, and of course lattice. When the atoms sit in a particular place, so what we call a BCC or FCC or so on and so forth, they also give certain properties. So this basically is the one that of course the table brings you quite a good amount of information that these properties of electron influences the properties. Properties of electrons or traits of electrons dictate the ultimate use of the materials, depending upon their charge or orbit coping and so on and so forth. So naturally we have a lot of scope. How do you manage? How do you twist? Or how do you control these properties? And what way they would like to serve us by controlling these traits of electrons. Next. Yeah. So this is the one. You may have seen the copper wire in your home or electrical wire. Electrical wire also do possess the resistance. That means whatever the power that we get from our common thermal plant, we are not able to tap this same amount of electricity or power. There is a loss in between, whether it is coming through aluminum wires or copper wires, but they have the resistance. So this, but there are materials which do not have any resistance, resistance equal to 0. So such materials we call as superconductors. So next question is, can we use them at room temperature? This material, but fortunately or unfortunately, these materials, superconductors, they are, when you take them to very, very low temperature, they lose the resistance, but not at room temperature. So your immediate task is, can we find out new materials which become superconductor right at room temperature? Those attempts are going on all over the world to push this superconductivity to room temperature. So once we are able to investigate or find out new material which loses its resistance at room temperature, I am sure all electrical lines will be replaced by this one, and we have no loss. Whatever thermal plant produces, so we can directly take to Hyderabad or to anywhere without any loss. But mind it, that this material has to be resistance-less. Resistance-less material has to be found out. So this is a task by itself to you, youngsters. So now we are able to, now a lot of efforts are going on to push it to room temperature. Of course, quite often you may have read in the newspaper that room temperature superconductor is found out. But room temperature superconductor, of course, under the pressure, it gives you room temperature. But the moment you remove the pressure, it becomes normal. That means no more resistive, no more superconductor. It is a resistive material. So this is another way of looking into this. When you grow further, there is a lot of scope to work on these materials for you. So it's a big chance for you. Next. So this nature is with positive and negative things. When you push one thing to the top, another one comes down. So these properties are inseparable. So they both go hand in hand. For example, if you want to have a material very, very high strength, so naturally the ductility, or in other words toughness, will also fall down. One rises up, another comes down. So one has to find out the ways to see how best we can optimize the properties. Yeah, this is one example I have shown. When conductivity is very high, the resistivity, well, it's resistivity is very high. Or in other words, conductivity, let me put it, because we are familiar with the conductivity. So when the material is very strong mechanically, its conductivity falls down. Conductivity falls down. Conductivity decreases. If I want a material with very, very high strength, conductivity falls down. So I have to balance how at the same time produce a material with both properties at optimum level, both strength and the conductivity. Let me drink water. As I told you, all materials, their properties depend upon the density of states which you have probably read in physics. So how these density of states differ from three-dimensional material that we deal with to two-dimensional ones, one-dimensional ones, and zero-dimensional ones. So how these density of states differ? So that directly influences the properties. So that one has to understand from the density point of view, density of states point of view. Physics probably, physics teachers must have told about this. So now we are familiar with the three-dimensional materials, but when we go down to zero dimension, how this energy changes. So this gives you a clear picture. So there is a lot of scope. When you find out a new material, you obviously are thrown or research what are the density of states. So that means there is a lot of scope at each and every level to find out what its properties are. Whether you talk from the physics point of view or chemistry point of view, but everything is open and there is a lot of scope to find out. Next. Yeah, here briefly shows it was 1947 when the first transistor was made by IBM. That time, the one transistor occupied space of 1 centimeter by 1 centimeter area. And as we know, 1 centimeter is 1 crore nanometers. So nowadays, the companies like Samsung, which you are familiar with, or Taiwan company, Taiwan Semiconductor Manufacturing Company, is making chips with 5 nanometers, 3 nanometers, and even now they are trying to produce 2 nanometer size. So you can imagine one single piece of transistor that we had in 1947 can have crores and crores of small transistors now. So that is the way the big computer has come down to so much down, and ultimately that has occupied your pocket in the form of a mobile phone. Earlier it was occupying this much building, 5-story building, but now it is coming and occupying only your, and who knows, when we make still further, it may look like your visiting card. So this is the way one has to imagine. So what are the advantages? Of course, it's very clear. What is the power saving in it? And what is the speed that one can improve upon? A lot of scope. So these are all the things that one can experience. And there is a lot of research going on to reduce the size. But production of 3 nanometer size is not that simple. A lot of problems are encountered, but the scientists never sleep. They keep on doing research to overcome these difficulties. So now Samsung is trying to produce, and who knows, next year or by 2025 or so, or 2030, that we'll have our mobile phone reduced to the size of one more getting coffee. Next. Yeah, this, of course, about carbon. Carbon, you are quite familiar with carbon, right? Coal, is a natural that we call coal. But touching the coal, you refuse to touch the coal because it spoils your hands black. So you don't like to touch it. But diamond is made out of carbon, you know that. But who throws diamond away? You all would like to jump for that. But after all, it is made from carbon only. And carbon, not only the diamond, which we are familiar with, after all, your pencil. Pencil lead is made from graphite. Carbon. And carbon, graphite, when you write it on a piece of paper, the thousands of layers of carbon come down on the paper that you are writing. Yeah, for example, you have a book. Any book. So this contains, let us say, graphite, contains thousands of layers of carbon. And if you are able to remove one by one and ultimately land with one layer of carbon, ultimately land with one atomic size of one atomic thick of carbon, you end up with an hexagonal structure of carbon which has very, very high strength. In other words, the strength of carbon or one atomic layer of carbon is very, very strong. Even strength is 1.2 terapascals, very high. And to put it in your parlance, so that you understand better, if I am able to make bag out of this one layer of carbon, a big bag, and put 100 elephants in the bag and tie it and throw it, bag will not get off. So that much strength it has, and it has electrical properties very, very high. And now Samsung and other companies are trying to make use of this. Graphene, one layer of carbon is called graphene, and graphene is Samsung companies and the other companies are going to replace normal metals with this. So those are the things that you have in, this out of this carbon, graphene, and it's transparent. And of course, the benefit of nanomaterials when you reduce the size from 3D to 2D, 1D and 0. So there are a lot of advantages. So this Fe2O3 that we have produced in our immediate is quite useful for advancing the microwaves. So this next. Yeah, many things that we can see everywhere, every part of our body needs protection. And first of all, detection. What kind of problem we do have? Unless it is detected, you cannot make use of it. You cannot further go. So the detection is done through various devices made out of materials, properties. So hence, once again, this brings again the need of materials study thoroughly from all its 6 properties. Thank you. Next. Yeah, this of course brings radio active battery, because the batteries quite often go bad. But this radioactive battery lasts 50 years. So once you charge, only after years you can tell your grandchildren to replace that time. Not now, but your grandchildren will replace it after 50 years. So that kind of thing is made in Russia, 50 using nickel 63. But further, one can make, if you use a strontium 90 also, in place of nickel 63, you can use strontium and promethium also. These materials are quite useful to prolong the life of the battery. Next. Yeah, this supercapacitor is made out of cement. Cement? Yes. Once again I am stressing. Cement. We wanted to work on this right in ABJ. So we are supposed to make it. So keep it in mind when you come to the 4th year, then probably you can take projects on this making supercapacitors with the cement. Next. Yeah, wood. Wood is also quite useful because now making metals, making structures out of metals, need a lot of energy. And every time you produce material, metal, you have to spend a lot of energy. Lot of energy means you have to burn coal to produce electricity. So while producing electricity from the coal, you are generating the carbon dioxide, and that is polluting the atmosphere. So naturally, since the wood is available everywhere, one can produce it, and of course you can make use of it for various things that you use in kitchen. So that benefit you can take an advantage of it. In fact, we also started working on this. Our fourth year students last year, they also worked on this and they found some interesting properties. But when you come to the 4th year, or even right now, if you are interested in approach or mechanical engineering professor Rajana is here, so he will also help you. So many other our mechanical engineering staff will definitely help you to work on this material. So come forward to work on this. And this ultimately is people there is a work on this material also to make it transparent wood and which can be used for your transistor. That one work I have seen recently paper, the Switzerland group or some group has made this transistor out of the wood. So there is a lot of scope for you. You don't worry that problems are over and there is no more work for your project. Thousands of projects are there. So don't worry about that. Next. Yeah, here you see. We will talk nowadays about the quantum computing. Everywhere quantum computing. So advantages are plenty. Nowadays we are using only 0 and 1 bytes based on traditional properties of electron. But see this, what one can do. Please catch my point here. Quantum computing, quantum computers or quantum technologies do a much out of two things. One is entanglement, quantum entanglement, and another is superposition. Quantum entanglement means the one electron can be coupled to an electron elsewhere, though they are not directly connected. Again, I repeat, electron, for example, right in this auditorium, can be connected to an electron somewhere on the moon. elsewhere at the end of the universe. Even that also I am telling you. Of course, a lot of experiments are going on. Chinese have succeeded in coupling one electron here, photon are particles of the light, one photon here, and another photon at 1,000 kilometers away at the satellite. So Chinese have successfully done it. But what is the proof that we have this phenomenon? Say, see these photos. I have myself taken the photograph in my home during night time. So see, can you see my photo? It's far off. This is the one I am talking about. So night time, only one light from the room is switched on. And see this kind of thing to prove that the light splits and meets again to give a complete picture. Otherwise, how do I get the complete picture? My own picture is seen here, and nowhere blockages have been observed. That means the complete picture appeared. So it once again shows there is a quantum entanglement at the level of the photons. Photons are nothing but the particles of light. So the bottom picture inspired me to see whether I can also take a photograph in my home. So after seeing this photograph at the bottom, I took the photograph there. At my home, you can also try today night, switch off the light, only put one light and go to the window. Like glass window, and take the photograph and come with the photograph tomorrow and show it to your teacher, physics teachers and chemistry teachers. So they will be more than happy that you have done real thing, yes. You do for next. Yeah, this quantum technologies, see now have invaded our land worldwide, and ultimately there is a scope that we are going to replace traditional computers with quantum computers. But quantum computers have to be put at a very, very low temperature, almost using helium. Helium nowadays is extremely difficult to get it. And that too, that helium having a characteristic of superfluidity. What I mean to say superfluid, I mean when you put the helium into this kind of bottle, it automatically comes up along the walls. So that's what we call a superfluid. So you have to put your computer to work at a very, very low temperature, almost at 0 degrees Kelvin. Almost at the 0 degrees Kelvin. So this helium 3, it gives you to go down to 1.4 Kelvin. So what I'm going to say is, these computers do work at a very, very low temperature because the principle behind it, that quantum entanglement and superposition is quantum mechanics. These properties have been taken into account while designing quantum computers. So their principles are based on quantum entanglement and superposition. So those things, quantum mechanics, do work at very low temperature. And of course, the advantage that you have with optical ones is good. That's why now Chinese are making use of this computer using light containing photons. And as you will see that photon in the previous slide, we have seen photons effect, and they are more stable than the electrons. So that's why now a lot of efforts are going on elsewhere to put more efforts to make use of photons rather than electrons to design these quantum computers. Next. Yeah, here comes, scientists are not just simplicity, right? They want to see, they want to play with the plants as well. Plants. And you have seen some animals, some butterflies, and so on and so forth. At night time, they give rise to light. How the light comes? So this principle, how they found out there is certain enzyme which triggers an acid in the animals, so that gives light. So why not do that kind of extraction of the enzyme and introduce into the plants, for example, that kind of enzyme is gene, let me put it in a more popular language, that kind of gene is extracted from the mushroom. Mushroom probably you must have eaten many times. So that kind of gene is extracted and put into the plants. The plants, petuna plants, and petuna plants also give rise to this kind of bioluminescence. Light during night time, just for 50 seconds, there is a video, link better, video cut, link, don't play that. Link better. Copy this. Now you see, is how these plants are giving light during night time. So don't you like to grow them at our home? So this once again, this brings us that there is a lot of scope for you to do research, whether it is directly related to the non-living things or living things. So plenty of scope is there everywhere. Only thing is you have to enlarge your scope. Don't limit yourself that you have a limitation, no limitation. So have you enjoyed? So shall I go to the next one? Hello? Okay, now there is a lot of scope. How do we relate materials to the informatics? So there is a lot of scope for you to correlate the properties of materials to information that we are seeking for. In other words, how do we develop materials for developing materials through various logarithms, computer software. So again, it comes back, unless you have the materials and the properties, you cannot develop. So you have to choose the materials in such a way, they will give you more and more information. So this slide is particularly to attract the people who are now being trained in computer science. So that means there is a good match or good tie-up with the materials. So don't neglect the materials. They are part and parcel of our life. Next. Yeah, this lot of materials are being wasted in the form of e-waste, because what? Now probably you have yourself thrown away your mobile phones after using for 1 or 2 years. But mind it, those things contain about 30 elements. So 30 elements are being drained into the ocean now. So how to reclaim it actually? So that the big research is going on, and this mobile phones or your motherboards contain gold as well. Gold. Who does not jump when one hears about gold? Everybody jumps. So a lot of efforts are being made, and we ourselves are interested in our right here, in our UJIT, to extract this material. Probably you can join our research to extract metals, including gold. Next. Yeah, this we have already started doing this kind of work, extraction of these metals. So we have initiated a lot more has to go into, but it's a preliminary experiment that we have done to make this material out of milk. Out of milk. When you boil the milk and put a drop of lemon juice, what it gives you? It gives you whey, W-H-E-Y. It is that you may have eaten a lot of times. So this is a waste material, actually the dairies, big dairies. So out of that one can make this extraction. So initially we have started with next. The 30 elements, as I was telling, of course, don't apply this zinc. This cream, generally whenever we wake up, before coming to the college, we apply very liberally cream on the screen. But that cream spoils your face. So it remains only for 2 hours, later it spoils your own face. So be careful. So this because one has to take next. Yeah, next. Next. Yeah. This how this after all electricity, power we need everywhere. Whether we are sitting in the auditorium like this or when we are operating your computer, we need power. But power is generated either burning coal or oil or gas. These all three give rise to the generation of carbon dioxide, which is polluting the atmosphere. So naturally you have to tune yourself to reduce the burning. So what are the methods? Other methods? There are various methods to extract the energy from the sun or wind, internal. Wind. So there are several ways. So one has to go for such methods to reduce the consumption of this one. Next. Otherwise, our global warming, I mean the more carbon dioxide we are inhaling, giving rise to or complicating our life with a lot of diseases. And fish also eats as much as we, but fish we eat. So we also are being troubled with this one. Mercury and other things, they are being taken away by fish, and fish we are taking. So that means we are also subjected to various kind of diseases, toxic materials. Yes? Yeah, this how this global warming is taking place. Last summer, you must have felt it. Very, very hot sun. Very hot sun. In fact, you rush to home to remain in the air-conditioned room. But so such kind of thing is going to happen once again because carbon dioxide level is more now. It is going more beyond 420 ppm. So this, if it goes further, we are all in trouble. Not only we are in trouble, but entire ecosystem is completely spoiled. By 1930, if this situation continues, if the emission of carbon dioxide continues like this, by 2030, 30% of the living species will perish, will die. 30% of the living species. And by 2050, 50% of the living species will perish. So that means it's very bad. Unless we control it, it's very difficult to live because we ourselves will be affected by many diseases if the temperature goes up. Right? Yeah, how these various things are affecting. You read it at the bottom. So how many people are being killed by use of various sources like oil, gas, coal and so on and so forth. And if we go to further renewable energy sources, the death rate will decrease. So naturally, this slide force to us, or forces us to reduce the use of gas, coal, and oil. Yes? So this slide brings very clearly that you have to reduce the consumption of other non-renewable resources like gas, coal. Yeah. Of course, I can prolong this, but let me. You are very familiar with this law. Physics law, you must have read it in your college. But many things are happening in the world. It is only, of course, related to the motion, gravity, law of thermodynamics, and electromagnetism. But is there anything missing in the world, law of nature? Of course, these are physical laws, but anything else is missing? Yes, scientists are trying to find out. So that is law of nature. So particularly, I don't like to spend time on this, but rush other slides. Last year there was a paper by the scientist, next. Yeah. You are quite aware of Darwin. Darwin, who has proposed the theory of evolution, how human being has come into being. So when he published a paper in 1871 at the end, there was a caricature. Newspapers brought out this kind of caricature of Darwin. But this evolution has taken place. Right? So now, similarly, he related to the living things, theory of evolution related to the biology and the living things. But is there any general law comprising not only the human beings, but even Beyond that, the scientists in USA have started working and published a paper last year. Quite interesting, but more details if you are interested, you can go through it. But keep off these things. Next. Next. Yes. So what I have already told, beyond this biology can we go? This is the scientists are trying to find out the answer for nature. Next. 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 Yeah, this, whatever the things that are happening, can we convert them in the form of bytes? For computer, you are very unfamiliar with bytes. So this information, whatever the information that is available to us, can we convert in the form of a byte? This is what the scientists have been doing. By doing so, they want to evolve with a loss of nature. That's what the scientists have been doing. And excellent paper last year it appeared. And of course, these are the papers that are available to convert into the bytes. At the bottom, I have given references. But if anybody is interested, you can always convert them. Next. Yeah, please read it. Please read it. Please read it. So science does not know anymore. So everybody can enlarge his or her scope to think logically and come out with a solution. It does not distinguish people based on any parochial tendency. So you're all in the race. What I mean to say is, everybody is capable of thinking. And always try to understand from science point of view why the things are happening. As long as we do not know science, we attribute to something which is unnatural. But once you know the solution or find out the real cause, you say, oh, this is the one. Earlier we were taught there was something else, and developed from devils there. So please do give a serious thinking from the science point of view, because we all understand. So this comes to an end, but a lot of questions are there. Because I want to be, as I told you from the beginning,